Good morning, grade 10. This is Mrs. Pascal. Today's section is Chapter 9, Quadratic Functions and Equation, Revision Part 2. Solving a quadratic equation. When we solve a quadratic equation, it means we need to find the intersection points between the graphical representation of the quadratic equation and the x-axis. So we will start by reviewing how to solve by factoring. As we learned before, we have many ways to factorize in order to solve a quadratic equation. Factoring using the sum and product method, factoring using the common divisor or common factor, factoring using the remarkable identities rules. So we'll take the first example. X squared plus 7x plus 12 is equal to 0 can be factorized using the sum and product rule. We need to find the product of two numbers where the answer of the product is 12, the sum is 7, so it's 3 and 4. Factoring using these values, it's x plus 3 into x plus 4 equal to 0. So we take each factor equal to 0, which gives x equal to negative 3 or x equal to negative 4. And the second example B, factoring x squared minus 5x plus 4 equal to 0 in order to solve it. Again, we need to find two numbers where their product is 4 and their sum is negative 5. So it's x minus 1 into x minus 4 equal to 0. Taking each factor equal to 0, it gives the roots x equal 1 or x equal to 4. In part C, 5x squared minus 10x is equal to 0. We have a common divisor 5 and a common variable x. We take it with the lowest power, so the common factor is 5x into x minus 2 is equal to 0. Taking each factor equal to 0 gives x equal to 0 over 5, which is 0, or x equals to 2. If we have an example like difference of two squares like x squared minus 36 is equal to 0, it can be factorized easily using the rule a minus b into a plus b, so it's x minus 6 into x plus 6 equal to 0. Taking each factor equal to 0 gives x equal to 6 or x equal minus 6. Solving by using the discriminant delta. To solve the equation x squared plus 7x minus 10 is equal to 3, first we need to rearrange it in reduced form. So it's x squared plus 7x minus 13 equal to 0. Then we need to define the real coefficients a, b, and c. Then using the rule of the discriminant delta is equal b squared minus 4ac, it gives 101. So delta is positive. Delta is positive, it means the equation admits two roots or two solutions or two intersections with the x-axis. So x1 is or can be calculated in the form of minus b minus radical delta over 2a, so it gives minus 7 minus radical 101 over 2, and x2 gives minus 7 plus radical 101 over 2. As I said before, the parabola intersects the x-axis at 2 points of intersection of coordinates x1 0, x2 0. For the equation 3x squared plus 7x plus 5 equal to 0, after we define the real coefficients a, b, and c, we need to calculate the discriminant delta, b squared minus 4ac, which gives minus 11. Minus 11 is a negative value, so the equation admits no real solution, and we can say that there is no intersection points between the parabola and the x-axis. In part C, for the equation x squared plus 8x plus 16 is equal to 0, when A is equal 1, B 8, and C 16. By calculating the discriminant delta, we get delta equal to 0. So we can deduce that the equation admits a double root or one intersecting solution with the coordinates x equal minus b over 2a, which gives minus 4. And we can say that the parabola intersects the x-axis at one point of coordinates minus 4, 0. Now we need to review the systems of linear and quadratic equation. Systems of linear and quadratic equation can be solved by calculation and by graphing, but today we will only review how to solve by calculation. So in order to solve such a system, we need to take y equal to y. Rearranging and reducing the equation obtained, we get x squared minus 4x minus 96 is equal to 0. So to find the number of solutions for this equation, we need to use the discriminant delta, which gives the value 400. So we have two intersecting points or two solutions. X1 is defined by minus b minus radical delta over 2a, giving the value negative 8. When we get the value of x1, we need to replace x1 by any of the two given equations to get the value of y1. But for sure, we take the equation or choose the equation with the lowest degree. It's easier for calculation. So we replace x1 in the first equation, we get y1 equal to 3. So the first point of intersection is negative 8, 3. The second point is of value x2 equal minus b plus radical delta over 2a, which gives 12. Replacing 12 in the first equation, we get 123. And so we get the second point of intersection of coordinates 12, 123. In example 2, the system is of equations y equal x squared minus 12x plus 30 and y equal 4x plus 30. So by solving it, we take y equal to y, rearranging the equation, we get x squared minus 16x equal to 0. We can use the discriminant way, or since it's incomplete form, we can take x in common easily and factorize the equation. We get x into x minus 16 equal to 0. Taking each factor equal to 0, we get the first value of x is 0 and y is 30 when replacing x in the second equation. And for the second term, when x is 16, we get y equal 94. So we have 2 points of intersection between the parabola and the straight line of equation 4x plus 30.